Hi there, my name is Garrett, and today I'm going to walk you through a take-home assessment that I received from Corsair for a data analyst slash business intelligence position at Corsair. And for this Excel portion, I'm going to provide the workbook in the description so you could download it and follow along with me. And I personally found it to be a good practice tool to sharpen my Excel and analysis skills, and as well as Power BI and creating dashboards and just working with data that you're not familiar with. So, in terms of this Excel portion, I do want to preface it by saying that we did have a 2-day timeline for the entire assessment. Um, and that includes the Excel as well as the Power BI dashboard and the PowerPoint deck that they wanted as well, which was an extra credit portion that you could do on top of the rest of the analysis. So for the Excel portion, we could only use Excel formulas to get the result. There was no manual calculations or filling in the result manually. We added notes and broke down steps where we needed to, and then documented them in a little a text box for somebody else to see. And then for each question, we need to create one chart based on the data provided. Again, if I didn't already mention this, we had a two-day timeline from when we first received this to when we had to send it back to them. And then the Power BI portion was merging two data sets together, cleaning them, and then creating a dashboard slash report. And that was very open-ended, and you can kind of use any methodologies for the analysis. And one last thing that they did want is to create manual calculations based on the data set. So for this video, I am going to just go over the Excel portion, but I may make another video depending on how this one does, or if there's another need for the Power BI portion, I will do that. But because Power BI is not accessible on Mac OS, I am only going to do the Excel today. So let's get started. So again, I've got the workbook downloaded in the description for you to download and follow along with me. So let's get started. With question 1, we have, what is the total sales of the headset in East region? So starting off with our data set, we have product, region, and sales. And the first thing that I always do with any data set that I receive is to go in and check maybe not every cell, but get a gist of kind of what the data set is looking like. And as I can see in multiple instances, we do have cases where headset is spelled out and it has extra spaces at the end, or in this case it has a period, and in this case it has a lot of extra spaces. So that's something to note for the product column. And then when we go through the region column, we also see again we have spaces after each entry, or even multiple spaces. So that's also something else to note. And when we go through the sales column, it seems pretty normal. So to get started, to make our model a little bit more flexible, what I'm going to do is add 2 input columns or input cells, and I'll name them product and region. And then I also want to make sure that I keep some amount of formatting. And then I'm going to put 2 cells here where we can enter in what we're looking for. So in this case, we are looking for headset, and we are looking for East. So we have product as headset and region as East. So now when we go into our formula, and in this case, we're going to be doing a sum ifs formula, where we can use multiple criteria to sum a range of values. And so our first entry, we're going to do the sum range, which is going to be the sales column. Criteria range 1, we're going to select the product column. And for criteria 1, because we have these extra spaces or periods at the end of the cells or the end of the entries, what we can do is add wildcards to the beginning and end of our at the end of our criteria. So we'll say asterisk, which is the wildcard symbol in a pair of parentheses, and then I'm going to select the I'm going to select B20. Oh, sorry. You know what? I missed the and symbol, which will be a concat function. We'll add another star. Sorry, we'll actually just do this in plain English. So we'll select B20 as our product, add another and symbol, and then another parentheses and another asterisk. Okay, so criteria range 2 is going to be region. I'm going to select the region column. Then again, we're going to add 2 wildcards, and we're also going to add 2 and symbols. And then we're going to add B21 in between there. And there we go. So we get our total sales as 339 for headsets in the East region. And the reason that we do add these asterisks again is to make sure that we include all variations of the value headset, despite there being spaces or periods at the end. So that's exactly what that wildcard is doing. So it'll say after headset, after that T, anything after, it'll include into that search. So here we go. In this text box, this is sort of the format that we're going to do, where we provide our assumptions based on the data set or anything that we find that needs to be noted. And this will be just a good practice to allow other people to understand your thinking when you're actually answering these questions. And I guess on the job as well, you'll be able to communicate how you got to a certain solution or a certain formula or value, just through simple documentation like this. So I won't do this for everyone, but as you're watching the video, you'll kind of understand these are the procedures that we're going through. So our first thing that we did was we made the assumption that the data set had multiple instances of headset with various entries such as spaces or periods, and it was also found in the region column. So when it came to the procedures, again, we're looking through the data set to find errors, and then we create sum-ifs formulas to specify the headset in the East regions with the wildcard function. This would include all of the instances of that value. And then lastly, we do have the sum-ifs formula written out completed. Again, this is a different way of writing it, where it says in quotations headset, and then we have the wildcard at the end. And so lastly, we do want to make a chart for all of these questions. Again, it might be a little tedious at first, but once you kind of practice these questions a little bit more, it becomes a lot smoother to actually go through and create a narrative or something interesting out of the data sets that are quite limited. So in this case, I decided to select all of the regions and then all of the products that make up the total sales. So in this case, I said the East region claims the highest amount of headset sales despite the lowest overall sales. So as you can see, we have headset in the dark blue with $339 in sales. And that is almost triple the North region, double the South region, and 300% higher than the West region, who had 0 sales. So something like this is just a quick way to visually represent sort of maybe a sales graph where you have multiple products and multiple regions, something like this. And then I also just realized that we need to make sure that our formatting is correct. So let's just go down and change this to currency and remove decimals. And there we go. So we have a sales chart. Again, you can do that with the data labels. I'm not going to do that, but just for instance, make sure that you kind of have these small details down, as they do come across very noticeably when you're going to give these to other people. So let's continue on. So that was question 1. We're going to move on to question 2. And now this question is asking, what is the margin for PSU in the North region? Again, the first thing that I like to do is just go through and check our data set, make sure everything kind of looks good. There's no particular way I'm doing this. I'm literally just clicking through random cells and just seeing if the formatting looks correct. Does everything look uniform? Is there anything that's awry? Anything out of the ordinary? And then our next thing to look at is actually what we're defining as our contribution margin and our margin rate. So what are we actually looking for with this data set? So after a Google search or two, we find that contribution margin is another way of saying the profit margin after removing all the variable costs. So in this case, I'm making the assumption that the contribution margin is going to be the revenue subtracting the freight costs, the hub costs, and the duty, which I'm assuming are all variable costs, to reach a margin. Now, I'm not exactly sure if this is also the same as profit margin, but just for the sake of this is how I approached it. And then the next thing they want is a margin rate. Again, we're taking the margin and dividing that by the overall revenue of the specific product. So that's exactly what we're going to be looking for. And our first step here in the analysis portion, if you would call it that, is to create a new column and just name it margin. And all we're going to do is take the revenue and subtract out our variable costs. So the reason I'm doing this is to remove the hassle of having to do multiple sum ifs inside of our formula, and this will just make it a lot easier to do our calculations. Now, it's not technically doing a manual calculation or filling in cells manually, but it is just another workaround to make it easier to work with. But then again, we can do that same thing where we take the name and region and put it down into some input cells. So we're going to say product name, and then we'll say region. Again, we will take a couple of formatting. There we go. Okay, great. So we are looking for the PSUs and the North region. So in this case, what we're going to do is a sum ifs formula using those two cells that we just chose. So first, our sum ifs, the first thing that we're going to add here is the sum range, which is going to be the margin. And remember, I already took out all of the variable costs, so this is actually the contribution margin that we're looking for. So now we just want to add only the values that meet PSU and North. So our first criteria range, we're going to select the name column, and we're going to select that. And then again, what we can do is say, well, we could really just select the cell here and then continue onwards, which is PSU. And then criteria range 2, we can select the region range, and then we can also select the North region and then use a closed bracket. And we want to make sure that we change this to a dollar amount, and there we go. So we get the contribution margin, which will be for PSUs in the North region. And we can verify this by going through and finding those two values. And we'll say 1745 and select that cell, and we get 3190. Okay, great. So now we can do our margin rate, which will be equal to the contribution margin. And then we're going to say, we're going to divide this by the revenue of those two same values, so for PSU in the North. So we're going to be looking for the revenue column instead of the margin column. So we'll do sum ifs. Our sum range is going to be changed to revenue. It's going to be the exact same formula as we just did for the contribution margin, except for we are selecting the revenue column. And then criteria range 2, we're going to select region, then go down here, comma, and close parentheses. And we get a long decimal, and let's just change this to a percentage rate, and we'll add 2 decimal places. And there we go. So we get $31.90 for a contribution margin and a margin rate of 28.23%. All right, so on the right here, again, this is exactly what I just walked through. We make the assumptions of our variable costs being these 3. Margin rate is the percentage of profit from that revenue of the product. And a version of the formula that I did, if it was hard-coded and we didn't have this, I think it would only be this. It would only be this formula as we're using the margin column. I guess instead of C, it would be G. So there we go. And let's move on to the graph here for this. I said SSDs have the highest profit margins over 4 times that of the PSUs. And I guess I didn't clarify this as well, but I am using pivot tables to create these charts. And all you really need to do is select the entire data range and then go up and click insert, and it'll be right here. You can say pivot chart, and this will create a new sheet with a pivot chart or a pivot table, and you can mess around with it and then copy and paste it back into this worksheet, just to make it a little bit easier to kind of work around. So in this case, I thought that the big difference in margin from PSU to SSD was rather important, considering that was one of the main things that they asked here. And I wanted to make that highlighted as a drastic difference. So using over 4 times to kind of emphasize that, that discrepancy. So yeah, let's continue. Our next question here, we have, what are Jimmy's gross sales? So again, let's go through our data set and just double check everything, make sure it looks good. And it looks like we have a pretty regular looking data set that's clean, and there are no errors here. And the first thing that we're going to do is understand what the question is asking. So it's asking for gross sales. And the 3 values that we have to work with are net sales, RMA, and a rebate. So if you are unfamiliar with sort of the, for instance, let's call it Best Buy. So let's say Best Buy, sells you a laptop, and 3 months later you want to return the laptop under warranty, whatever. They will give you a refund for your money for whatever you bought the laptop for. So that is actually going to be a RMA, which is Return Merchandise Authorization. So it says, or actually it could even be a distributor. So maybe Best Buy is actually returning this to the distributor, something like that. So it's going to be return of a product, and you have to give the customer their money or give whoever it is their money. So that's what an RMA is. And then a rebate is going to be a small reward for purchasing a product. Again, you're paying somebody else for making that purchase. And so what we want to do is actually add these values back into our net sales. So net sales is going to be everything after we've taken out the RMA, the rebate, expenses, taxes, whatever. So net sales is going to be the last value, the bottom line value that we are looking at. But the gross sales is the top value. So that RMA, even though you sold a laptop and a customer returned it, you still have to count those as sales. So they were actually refunded. So if we say the net sales was this, but we also had refunds, so that would be the gross sales here of 2,100, and then we add back rebates. So our gross sales were actually 2,275 for Joseph. Let's just say as an example, and then up here we can also make sure that we title this as gross sales. There we go. So we're going to use that same formula all the way down. And let's copy and paste the formatting again. I know it's a small thing, but it's just a little difference maker that I notice. So there we go. We've got gross sales for all of our salespeople or sales representatives. And again, what we can do is just add a simple cell that says sales representative. And we'll add a little input box where we can write Jimmy, who is who we are looking for. And again, let's keep some formatting here just for the sake of the example. And we'll say the gross sales of Jimmy are going to be using a lookup formula. So we're going to use X lookup. If you're not familiar, it is a way that you could search a value inside of an array and then return a separate value. Essentially, all we're going to do here is select the lookup value, which is Jimmy. In this case, B20 is the cell that we chose. Our lookup array, this is going to be the array that we are looking for that value in. So obviously, we're going to choose the name column. And then the return array, we're going to choose the gross sales column. And this will return the value for Jimmy and his gross sales. So let's hit enter. And there we go. We get 993. And we can go back and change this to be a dollar amount. And there we go. And so if we change this to be any other name or representative, we can see that there are changing values, and it is a more flexible model than if you just hard-coded the name into the formula. So let's change this back to Jimmy. And there we go. So we get 993. And for my graph, I chose to really just show the drastic difference between Jimmy and Juno, who Jimmy has the lowest sales, net sales and gross sales, whereas Juno has the highest, and he has nearly four or five times that of Jimmy's. And so it's a pretty notable difference in terms of the graph, and you can actually see that the difference, the difference in gross sales to Jimmy's gross sales is literally four times. Whatever reason that might be. In this case, it could be Jimmy's a new associate, whereas Juno is a 10-year veteran who's been selling all this merchandise for years on end. So yeah, I just thought it was kind of an interesting graph to choose. Again, I'm using a pivot table to create this chart, and then I copy and paste it back into the worksheet just to make it a little bit easier for other people to see and kind of work through. So yeah. Let's continue on. So we have question 4. This one is a little bit of a doozy, so hopefully I explain this properly. Give me just 1 second. I need to grab some water. All right, so question 4, we're going to say, arrange the data into the table on the right. So our table that we're looking at is country, year, and rate. And we get Brazil, UK, Germany, US, India. And we get a bunch of different years. And then we get a bunch of different rates as well. And I would say the one thing here is to make sure that we don't have duplicates for, say, the same combination of China and year. Or US in year, Brazil in year. So if there are two values where it says the same country and year, that could be problematic. So just keep that in mind when you are looking at this. And so the first thing that we're going to do here, again, we already looked through the data set. It looks fairly normal. Again, you could do a hard check on the duplicates, but I'm choosing not to here. And what we're going to do is we are going to use the XLOOKUP formula again. But in this case, we're going to do something a little bit different, and I will hopefully explain this as well as I can. But we're going to choose the lookup value as 1. So we're going to set this as 1, and we're going to set our lookup array to be the combination of the year and the country. So what I mean by this is we are going to set the year equal to the year column, and we are going to multiply this by H5, which is US. It's hidden underneath the formula. Then we're going to go over here and select the country column. Then we're going to use a close bracket, and the return array that we're going to select here is the rate column. So let me quickly explain kind of what this formula is doing. So this is saying only when we have these two criteria met will we return a 1. If we don't have one of these criteria met, we're going to return a 0, and that's going to result in the value here being 0. Thus, it won't actually return a value at all. So only when the value is found is when you're going to get a return value. So let's go ahead and let's do a quick modification so that we can use this formula across the entire table. Sorry, that was C5. And we want to make sure that we're locking all of the data tables or all the columns here inside of this formula. And we do this by using the $. And because this is H5, this is the country column, we just want to make sure that H is locked and 5 is unlocked, so 5 can move up and down. Then B5 we're going to lock, and B44 we're also going to lock. And the rate column we are also going to lock. Okay, great. And there we go. So we get 0.83 yada yada yada. And in this case, we see US in 2015. And if we go ahead and open up all of these decimals, sorry, that is not the correct value. Oh, you know what? That is actually kind of interesting. Oh, that's why I rounded it up. I was on the wrong cell. So 0.8397, 0.8397, that is the same cell that we're looking for. So let me kind of demonstrate what this middle part of the XLOOKUP formula is doing. And if we go ahead and paste this, here's the array that is sort of outputting. So if this makes more sense to you, this might be a good formula to get some practice with. So in this case, it's returning a 1 in the 6th position. It's saying this is the value that we're going to return because both of the values are equal to 1. So if we visually kind of look at this, we're saying we're looking for the value of 1, and then the lookup array. This is going to be our array right here. This is the array produced. I think I just messed it up. Let's get rid of that. Sorry. And then the return array obviously is going to be the rate. So this is sort of how this formula is actually acting. And it can be a pretty powerful kind of way to navigate things. So let's go ahead and quickly get rid of these extra decimal places just for simplicity. And what we'll do is double click the bottom right of the cell. And then we're also going to drag it across all of the years. So we can go ahead and verify this. So we'll say Brazil in 2017. Go ahead and click enter. Again, we're just going to double check and make sure our formula is correct. Sorry, that was the value that we're looking for. I was just trying to grab the center here just to demonstrate again kind of what this formula is doing. So it's producing the array. So we get all zeros, and then we only have one instance of 1. Now, I guess if you had duplicates, you could have 2 1s show up. And in that case, I'm not sure what would happen. But this is how I'm doing it. So hopefully that works out. Now let's move on to the chart that I produced here. Again, this is the formula. And it does look a little bit crazy. Feel free to leave a comment on your approach to this chart. I really didn't know what to do here because this data set is pretty ambiguous. It's just a random rate, and there's not really much else information. You get years and different countries, and so there's a lot to kind of make up. So in this case, I say US and UK experience opposite reactions to market efficiencies. Just a random thing that I thought would be applicable here. In the y-axis, I say cost efficiency ratio. On the x-axis, I have the year, and then the lines are each individual country. So as you can see, just a drastic difference between both of the countries. Sort of just trying to make up a narrative to give to somebody else or to give to a stakeholder and provide a little bit of significance behind a random set of data. So let's continue. Let's go to question 5. And question 5 is complex data process. Our order table has several data points collected around financials and location. Question 1, we want to categorize orders based on their revenue into one of 7 bins. Using their revenue tier table, write a formula under the bin column in the order table and assign a bin number to each record. So the bin table is down here. It makes a lot more sense than it is written. But essentially it's saying, here's the revenue, here's the bin, and here's the range. So we've got a lower and upper range, and each bin value, bins 1 through 7, and a particular asking price. Question 2 is write a formula that calculates the number of distributor orders in Illinois. And lastly, we have write a formula that calculates the median cash flow for orders in New Jersey. Note some orders may not have a cash flow value filled out. So we do have some null values in our data set. And one of the assumptions that I'm making here is to leave this as a null value and not try to produce a value. And the reason for that is you can kind of get a very wide range of values here in terms of, say for instance, the revenue, the gross sales, and then the cash flow. If we're looking at revenue, gross sales, and then cash flow and try to kind of interpret or extrapolate what we have here and kind of fill in these null values, it could really throw off the data set. So let's hop right in. We'll start with the question 2 just for the sake of going through these questions. We'll say write a formula that calculates the number of distributor orders in Illinois. So the formula that we're going to use here is count ifs. And the count ifs, again, ifs will allow us to use multiple criteria. And our criteria range, we're looking for distributor orders and Illinois. Those are our two variables that we are searching for. So we're going to start with our state. And we're going to say when the state is equal to IL, which is Illinois. And then our next criteria range is going to be the channel. And we're going to select the entire column. And in parentheses, we're going to add distributor. Close parentheses, and there we go. So we get 3. Again, we can go ahead and verify this. So we get New Jersey once, New Jersey, sorry, we're looking for Illinois. Illinois once, Illinois twice, Illinois a third time for distributors. All right, and so write a formula that calculates the median cash flow for orders in New Jersey. So the approach that we can do here is use a combination of 2 formulas. The first formula, or the function that we're going to use, is median. And we're going to do the median calculation only if we have the state of New Jersey. So that's what we're looking for. We're looking for the cash flow for orders in New Jersey, and that's simply put. So we're going to select our state column. We're going to select the entire column if I can properly grab the column here. Okay. And we're going to say when this is equal to NJ, and then close parentheses, and the value if true. So the value of true is going to be the cash flow column, and we can simply close the parentheses after this. And we'll close it one more time, and that will be our formula. So we get a median cash flow of 294,000. Let's get rid of some decimal places. And there we go. So again, that's just taking the median cash flow. So it's taking the average. I suppose you could also use average instead of median. Let's see. Same thing. So you'll get the same result, but there you go. And lastly, we have our, well, I guess our first question. So we want to organize the orders based on revenue into 7 bins. And so for each of these orders, we want to select a bin that it belongs to based on the revenue column. So the first thing that we can do here is we'll say index. And the array that we're going to index is the bin array, or the bin column down here. And then we'll add a close parentheses and we'll say match. So the match function, we're going to say our lookup value is going to be the revenue. So we want to match the revenue against a specific value. In this case, it's going to be the one of the sides of the ranges. In this case, we're going to choose the lower range. And then our lookup array, let's see, our lookup array, lookup value, lookup array. Oh, I'm sorry. Here, let me delete this. Go through this again. So lookup value, we're going to say revenue, comma, our lookup array, the lower portion of the brackets, or the bin ranges. And then the match type we're going to choose is less than. And the reason being is when we choose less than, it will allow every single value that we have to end up in a bin value. So what I mean by that is, let's say for instance, our first value here, let's go ahead and hit enter, we get 7. So does 7 check out with 1.8 million? When we go down here, we look at all the bins and we say, is this value less than 1 million? No, it's not. It's not less than a million. So this is actually going to be the bin value that we choose. Let me go ahead and drag this down a couple more, and I'll show you exactly what I mean by this. So next we get, oh, excuse me. Let's not drag the formula down just yet. Let's make sure that we lock our ranges again. 15. There we go. So we're going to go ahead and lock the ranges. The only thing that we're not going to lock in here is the revenue, which is B15. So the B column we're going to leave alone. And we're going to go ahead and lock the rest of these. There we go. I'm sure there's a shortcut on Mac. I truly don't know it off the top of my head, so I'm not going to bother with it, but make sure we lock these before we start dragging things around. Okay, so that value is incorrect. Oh, okay. I see what happened. Sorry. My apologies. This should be 40. 41. There we go. This is why we double check. Okay. So now we're back. We have 7. Let's go ahead and drag this down to 2. And so the next value that we get for 375,000, we get bin 5. So why does it end up in bin 5? So bin 5, we'll say, well, 375,000. Is it less than $1 million? Yes, it is. Let's move on to the next bin. Is it less than 500,000? Yes, it is. Let's move on to the next bin. 300,000. Is 375,000 less than 300,000? No, it's not. So this is going to be bin number 5. And hopefully that makes a little bit of sense. So if we go to, again, 150,000. So we'll say, is it less than 200,000? Yes, it is. Is it less than 100,000? No, it's not. So it's going to stop at bin 3 as the range that it ends up in. So that's how we use the XLOOKUP, or sorry, the index matching with the less than match type. And we'll go ahead and just complete the rest of this. And there we go. So let me zoom out a little bit so you can see my chart. And in this case, there really wasn't much special. I just chose to look at the cash flows of all of the top grossing states, and then I produced a chart going from the greatest amount of cash flow to the lowest amount. And in this case, you find an interesting pattern where Georgia has the largest amount of cash flow in a other category for the channel, and then the next 3 highest cash flowing states are based from distributor channels. We have Rhode Island, South Carolina, and then Illinois as well. Again, I'm using a pivot table to produce this chart, and there really wasn't anything special that I did. All I had selected was, I believe it was just the cash flow, the state, and then the channel. And that's what we ended up with. All right, so let's continue on. We'll go to question 6. This is probably the easiest question that we have, but is use rules to highlight the cells where the sales are less than 100. So what we'll start off with, again, let's go ahead and make sure that we have our data set clean. And by the looks of it, it looks great. So we select sales column entirely. We'll go up here and select conditional formatting, highlight sales rules, and then click less than. And you'll have a little pop-up box that says new formatting rule. Our formatting rule is going to be less than, so cell value less than. You can change this to be a different set of values if you're looking to find a more specific thing, but we have less than as our choice. And we can select a yellow fill with a dark yellow text, or a red fill, a different color, etc. So let's go and hit OK. So I actually completely messed this up. I clicked greater than. This should be less than. Let's do this one more time. Sell value less than 100. There we go. So we get two values of January and September where the sales are less than 100. And the chart that I produced here is January sees the lowest sales despite the highest sales number of units sold. So the sales amount here, so we have a very low sales amount but a very high number of units sold. And that's a drastic change to March where we have only 3 units sold versus $360 in sales. So something to note based on the data set. All right, so let's continue on. The next question that we received is, show good in the results column if the distance is below 200 and the cost is below 50. So again, we get location, we get distance, and we get cost, and then we have results. And just quickly double checking, everything looks good. So let's start by producing our formula. So we're going to say if and. So this is going to be a different approach, but very similar to the previous formulas that we used, where we're using two different say for instance, the countifs function, we were able to do a accounting calculation with two different criteria. But in this case, because we are outputting a string, we're not doing a calculation per se. We're looking for a true false sort of, again, a binary response from the distance and the cost to output a specific value. So in this case, we're going to say if and we're going to say if distance, so we're going to select the distance cell, is less than 200, comma, cost is less than 50, close parentheses, comma, value if true, we're going to say is good, and then the value of false, we're going to leave as blank. And close parentheses. There we go. So we're going to double click on the bottom right of the cell. And there we go. So we get 4 results from our data set that say these meet the criteria that we just were looking for. And so I show this on the graph. Again, I actually didn't use a pivot table, but I used a regular table, and then I selected the data labels as the location column. So in this case, we have 4 different locations that meet the criteria out of the 18. I should say only 4 out of 18 locations meet the desired constraints that they are looking for. And there we go. All right, so this question, we have question 8, which is extract the numerical quantity numbers into the highlighted cells. So I want to preface this by saying this was the hardest question that we had in the Excel take home. And I'm unfortunately not going to show you the version that I produced at the end of this submission, but I will show you the much quicker and easier way to solve this problem. So when we look at our data set, we have a column that shows our different products. We have accessories, keyboards, headsets, and mice. And it seems as though everything looks identical or looks good here. I guess if we converted this into a table, we could actually do that as well, but we would, but we're not going to do that. The next thing that we see is quantity, which is quantity, a value, and then unit, a quantity, and then a value, quantities, and then a value, and then quantity with a value, and then units, and so on. So you see that there's a variety of different ways that the cells are formatted, and our job is to only pull out the numerical quantity values into the highlighted cells. So if you do actually know how to answer this question more efficiently, please let me know how you would produce a formula for this question. I would love to know it. But otherwise, we're going to do something so much easier and so much less of a hassle and so much more efficient than anything out there. So we're going to start off with something very simple, which is we're going to say 212 is the first value that we see and that we are looking for. I'm going to click enter. The next thing that I'm going to do is hit Control E. I'm going to move down one cell and hit Control E on the keyboard. And that will flash fill all of the remaining values that I'm searching for and trying to pull out from the cells. That's it. That's the solution. Unfortunately, the solutions that me and a peer had come up with were significantly more complex and hard to explain than something like this, where it's very straightforward and easy to do. So we get our values pulled out, and that's exactly what I sort of describe here. Our procedure is writing 212, move to the cell below, and then hit Control E, and it'll autofill the rest of the values. And then I made a simple chart here which says headset leads in total orders amongst computer peripherals, where it's almost double the accessories and triple the amount of orders for mice, and a little bit more than, say, 40% of the keyboard order counts as well. And there we go. So let's move on. So we have question 9, which is fill in the sales and model ID columns with the top 5 and bottom 5 models by sales. So when we look at our data set, let's go and zoom in a little bit. So we have model and we have sales. We have a model ID and a sales value. I guess we can also switch this to be a table. And if we go in, we can see all of the values that we have. I don't know if there are any duplicates from doing this. I don't know why I did that, but something to do. So let's start with our formulas. So we're going to look at top 5 models. We have we have the rank cell, or the rank column, the sales model, the sales and the model ID. So in this case, we are going to use the function called large. So large will find your largest value of an array. And our value that we're going to search for is the sales. We're going to click comma. Actually, here, let me remove the table just for the sake of the simplicity here. So we're going to say rank 1 sales, large, parentheses, sales column as our array, and K we can select as the rank, the rank cell that's to the left of the sales column. And what will this allow us to do is be more flexible again with how we use our formula. And let's make sure that we lock the sales array and hit close parentheses. All right, and we can verify this by selecting our sales column. The largest value here is max 868.35, which we have right here. So let's go ahead and drag this formula down one, and we'll drag it down one more. And we can see these values are decreasing, so we know that it is actually working correctly. And there we go. So the way that this works is we're looking for rank 3, so the third largest value of the data set, and the 5th largest value of the data set here. All right, so we can use the same formula, but in reverse. So instead of large, you guessed it, we're going to use small. So small, we're going to find the smallest value of the array, and we're going to make sure that we lock the cells for the array. And then we're going to select K as our rank, or the rank is K. Click enter, and then we'll double click on the bottom right of the column to autofill the rest of it for us. So there we go. And now our last step to create the model IDs for these values is to use the XLOOKUP function. We're going to say the lookup array is going to be the sales column. It's not going to be the model ID. It's going to be the sales column. And let's go ahead and lock this. Lock that array, comma, lookup array. Sorry, I missed. So the lookup value is actually going to be this first value, comma, our lookup array, and then our return array is going to be the model ID. So that's going to be the value that we are returning after we find what the sales number is. So in this case, we're going to get 29V as our first result. And let's go ahead and make sure we lock the array again. And then we can go ahead and see if this result matches. Click parentheses and enter. So we get 29V3 as our highest sales model. And then we can go ahead and double click on the bottom right, autofill the rest of it. And here we go again. We can actually copy and paste the same formula. And all we're going to do is adjust where that starts. So instead of E11, we can change it to be E15. Click enter and double click the bottom right. And there we go. So if we want to verify again, so we can click a random value, we get 50.2, and we go ahead and look at our sales, 50.2. 94N9, 94N9, perfect. And one last thing, we can change this column to have a formal amount of decimal places, again in this column as well. And there we go. And so the graph that I produced here was, I took an average of all of the total sales for each of the product IDs, and put them on a horizontal bar chart where we can compare the averages, or the average, against the total amounts for each product. And in this case, we only have 7 models that exceed the average amount of sales for these products. Again, I did actually use a pivot table here to pull out these values. And for average, I actually just simply wrote average down here and then did an average of this column to produce that. But if you find a different way of approaching it, feel free to do that as well. Again, these are very open-ended, so this is just the kind of approach that I used. All right, so our last question here, we have data adjustment, pivot table, and chart. So pretty similar to everything that we've been doing up until this point. And so our instructions here, let's go ahead and zoom in so you can read it. So it says, using the data table on the right, fix the spelling error of Corsair and explain how you fixed it. Any method other than manually changing the individual cells is acceptable. Optional, use a macro to solve this. So I do not know how to use macros, but if you do, please feel free to leave a comment on how you'd approach this, because I would be curious too. So the first thing that we're going to do here is actually just make this entire data set into a table. And the reason being is we want to check for the spelling error that we have in Corsair. So in this case, if you can see it, we have Corsair spelled correctly. And then we have Corsair, but the I and the A are misplaced and switched. And then we have Elgato, Origin, and Scuff. So what we can do is actually just select the error and have a look at that. So we have, several instances where it is misspelled. And so we'll keep that as something to note. The next step that I took here was, let's go and move this, was to create a new table, and we'll name this brand. And we'll say brand correct. Brand underscore correct. We'll leave it as that. And then we'll also add the formatting. And let's put in all of the values for the correct spellings of the products. So we have Scuff, Corsair, Origin, and Elgato. And let's go and transfer over that formatting. And there we go. So the reason for this is that we are able to, sorry, this is bothering me. Why is the, how do I switch these? I actually don't know how to change this to be alternating, but that's okay. Besides the point. So the step that we're going to take here is to see if the brand column matches the brand correct column. If it doesn't match this column, we're going to actually leave it with a different value. So what I mean by this, here, let's go ahead and insert a new column into our table, and we'll say this is brand and then underscore mod. And our formula that we're going to use here, again, is going to be very similar to the formulas that we used before. And what we can do is a simple XLOOKUP function. So we're going to say the XLOOKUP parentheses lookup value is going to be the brand in the left, comma, the lookup array is going to be the brand correct table. The return array is also going to be that same table. And let's go ahead and lock everything. And then our value, if not found, we can do parentheses Corsair. And the reason for this is that because we know there's only one misspelling of Corsair, we can simply use that as the only other option when we're comparing the brand to the brand correct table. So let's hit enter, and there we go. So we get several cases. So if we go ahead and select the brand mod and click on that drop-down table, again, we only get the 4 instances where it says Corsair. And if we're looking at the original one and we hit select and we click on the misspelling, we can see that the misspelling now has a new entry of Corsair on the right that wasn't there before. So let's go ahead and return our table to the original formatting. And the last thing that we can do here is, just for me, we'll change sales to be a dollar figure with 0 decimals, and we'll change the units to be a comma or a regular value with no decimal places as well. And so after we make this new brand, the brand underscore mod column, you could actually go ahead and delete the original column. Actually, don't delete the original column. You can copy the entire column over itself. So you copy the column, and then we can say paste special, and we'll say paste values. And so when we paste values, instead of that formula that we used earlier, we only get the text for each of these. And then you can go in and delete that entire original column from the table. As a matter of fact, you can delete it completely because you don't need it anymore. If we go ahead and delete, there we go. So now we've got a brand new table to work with. And here's that exact formula again. So we get XLOOKUP, the brand, the whether it's misspelled or not, the lookup table that we had over here, and then Corsair, the only other option that you could use. So let's go ahead and zoom out and look at what I had produced for our graph. So the graph that they were looking for is create a time series chart and a pivot table showing the top 5 products by sales, top 5 Elgato products by sales. So in this case, we use our pivot table. This is not a pivot table, but in another spreadsheet, I had the pivot table open, and this is what I came up with. So I chose to look at the products by month, but also by the total percentage of revenue for each product. So in this case, I noted that cameras and microphones account for over a third of Elgato's revenue. So as you can see, the camera and the microphones are the gray or the light gray and the light blue down here. And I thought that was a interesting thing to look at. I guess you could also look at individual products as well. So you could say there's variances in, say, the lighting products across months, or January and June saw a large dip in sales as compared to previous months. Where the lighting sales are producing 25%, which is a large difference, over 10% from previous months. Despite the overall decrease in sales. So not too complicated in terms of what we're looking at, but it's a simple chart to demonstrate sort of what the data set might be sort of looking for. And yeah, so that was one way that I had thought about of doing it, but I'm sure there are plenty of other insights that you can pull out from the data set. This was just something that I come up with based on what we had. So we have sales, we have units, and we have the date, as well as the category for each of these products as well. And so, yeah, that is the wrap up in terms of the Excel portion of this take-home assessment. I hope you found it helpful to follow along with me as you are completing this. If there are steps that I had missed, or you have further questions on sort of how to do something or how I did something in this video, please leave a comment down below. And if you did find this helpful, I can continue on with the rest of the analysis. There is the Power BI portion that I could also make a video on if you deem that to be something that you'd like to see. So hopefully you guys did find this useful. And again, I do think this is really good practice as someone who's trying to become a data analyst. This really exposed me to not only Excel in a more complete and thorough fashion, but as well as creating these charts that I can present to other people or potentially put into a PowerPoint to show to somebody else. So yeah, hopefully you guys enjoyed. Let me know down in the comments below, and I will see you guys later. Bye.